In this question, we're asked to solve the inequality 1 over 3 multiplied by x minus 1 over 4 into bracket x plus 2 is greater than or equal to 3x minus 1 whole number 1 over 3. Now, looking at this question, we are seeing that we have 3 and 4 as the denominators. Their LCM is 12. So, the first step for us is to multiply both sides by 12, which is their LCM. Notice that we are going to be multiplying the whole of the entry. So, we have 12 into 1 over 3x minus 1 over 4x plus 2. 12 is multiplying all the entries. And what we do to the left hand side, we do to the right hand side. So we also multiply the right hand side by 12. But one whole number, 1 over 3, is going to give us 4 over 3 if we convert that to a proper fraction. So we just open up the bracket and multiply each of the entries with 12. We are going to have all this is greater than or equal to 12 multiplied by 3x minus 12 multiplied by 4 over 3. So now we can cut 3 can go in 12 4, 4 can go in 12 3, 3 again can go in 12 to be 4. So we have our equation to be, our inequality to be 4x minus 3 into x plus 2 is greater than or equal to 12 times 3x is 36x, 4 times 4 is 16. Okay? So with this, we can just open the bracket further. This will be 4x minus 3 times x is minus 3x. Minus 3 times 2 is minus 6 is greater than or equal to 36x minus 16. So if you are to collect like terms, put the constants together, put the ones having variable x together. We are going to have, okay, first 4x minus 3x is x minus 6 is greater than or equal to 36x minus 16. Okay, so when we now collect the like terms, x minus 36x is greater than or equal to minus 16 plus 6. This will give us minus 35x is greater than or equal to minus 10. Minus 10. Okay? Now, this is where we need to be very careful. We want to actually find the expression for x. So normally we would have said we want to divide by minus 35. But what happens when we divide an inequality? Notice that this is not an equation, it is an inequality. If you want to divide an inequality with negative number, what happens? Let's take minus 4 and minus 2. If we divide minus 4 and minus 2 by minus 2, we are going to have 2 and 1. But initially, we know that minus 4 is less than minus 2. But 2 is greater than 1 when we divide that by minus 2. So, as a rule of thumb, it is that the sign changes whenever we are dividing or multiplying an inequality with a negative number. Okay? So, if you have minus 4 and minus 2, you divide both sides by minus 2, the inequality sign will change. If it is less than before, it will become greater than. If it is greater than before, it will become less than. Okay? So, here, if you apply that principle, 2 can go, 5 can go in 10, 2, 5 can go in 35, 7. So we now have x is less than or equal to 2 over 7. It's not that x is greater than or equal to 2 over 7. No. It's x is less than or equal to 2 over 7. Now, after doing a question like this, as a rule of thumb, it is always better that you always draw your number line. Even if you are not asked to do that, to get your full mark, especially in theory questions like this, just also draw the number line. It's not going to take you much. Just in this particular case, we have 2 over 7. So I can use a scale of 1 over 7 on the number line. Okay, this now be 3 over 7. And then I will locate the point 2 over 7. But I'm noting that I'm having less than or equal to, because of the or equal to that is there. That's going to be a shaded circle. If it is just less than, that will be an empty circle. Then less is towards the left. And this is the solution to our inequality. In this question, we are told that ABC is a right angle triangle on the horizontal ground. Okay, so we can try and just note that the triangle ABC is a right angle triangle, but it is on the horizontal ground. Okay, so this is the ground level. Then we are told that AD is a vertical tower. So the line AD that we are seeing is actually a tower. Angle BAC is also 90 degrees. Okay. Then angle ACB. ACB means we start from A, go through C and B, that's 35. Then angle ABD is 52. Then BC, the line BC is 66 meters. Now, using this information that I've been given and the diagram, we are to find correct to two decimal places the height of the tower and the angle of elevation of the top of the tower from point C. Okay, first from the question, we are asked to find the height of the tower, that's AD, okay? And then we're asked to find the angle of elevation of the top of the tower from C. The angle of elevation of the top of the tower from C. The top of the tower is D, then the angle of elevation from C means that we go from C, and then we know the horizontal ground is coming from here already. So the one being shown in red is the angle of elevation of the top of the tower from C. That's angle theta. And that theta is angle ACD. So we are looking for AD, height of the tower, and the angle of elevation of the top of the tower from C. That is ACD. Now, how do we go about solving this and looking at the diagram and the information that we have been given to solve for this? Now, looking at this particular diagram, we are seeing that we're having right angle triangles. And so, two theorems that will seriously help us to solve this is the Pythagoras theorem and SOHCAHTOA. Okay, the trigonometric function SOHCAHTOA and Pythagoras theorem, they are going to help us a lot in solving this particular question because we are seeing right angle triangle. So if you want to use that to solve, like in the first case, we want to get the height of the tower AD. Now, we don't have full details of the triangles that are erect. We have quite a number of detail on the triangle that is on the horizontal ground. Okay. Now, to get the line AD, which is the height of the tower, we need to get the line AB from triangle ABC. Because if we get AB, then we can use trigonometric function with 52 degrees to find AD. But first, if you look at the triangle ABC, the one on the horizontal ground that I'm replicating in my diagram again, we have this as 90 degrees at point A, we have this as 66 meters, then we have this angle at C to be 35 degrees. If we want to use SOHCAHTOA, we can see that already we have the hypotenuse in this particular triangle, that's BC. Now, the side opposite the angle that we are given is going to be appended as the opposite. So we have the hypotenuse, we have the opposite, and AC will be the adjacent. So what formula do we know relates the opposite and the hypotenuse? Since we know the angle is 35, the formula relating the opposite and the hypotenuse is the sine. Okay, so we can say sine 35 is opposite over hypotenuse, and the opposite is AB, the hypotenuse is BC. That hypotenuse is 66. So you can put in the value as 66 such that we can say sine 35 is equal to AB over 66. And if we cross multiply that, we'll have AB, the line AB, is 66 sine 35. So I can bring in a calculator to try and solve for that. 66 sine 35. That's 37.856 meters. Okay. So that is the value of the line AB. But I'm just first getting the line AB so that I can use it in the other triangle to get the height of the tower, the line AD. So if I'm now to consider the triangle ABD from triangle ABD, I can now say, let me just even draw the triangle out. So I have this triangle, just separating it out of the whole diagram. I've been told there is a right angle there. We have BD and A. AB, we just got to be 37.85 meters. Okay, so this is AB 37.856 meters. Okay, now with respect to 52 degrees, AD is the opposite, then BD is the hypotenuse, while AB that we just got is 37.856. Here we are looking for the opposite, we know the adjacent. From our trigonometric function, it is the tan that relates the opposite and the adjacent. And we know that tan 52, since 52 is the angle of consideration, is opposite over adjacent. The opposite is AD and the adjacent is AB. AD is what we are looking for. AB we just discovered to be 87.856. So we can now say, just like in the previous case, if you cross multiply, AD will be 37.856 tan 52. So if you just put that into our calculator, 37.856, that's our answer, tan 52. This is 48.453 meters. Okay, 4535 meters. Okay, but we are told to get our answer correct to 2 decimal places, so that will give us 48.45 meters to 2 decimal places. Okay, so the height of the tower, which is the line AD, is 48.45 meters, correct to 2 decimal places. So with that being done, we can now go ahead to find the angle of elevation of the top of the tower from C. All right, let's see how we can go about to solve that. That's the other question that we're asked to solve in our question. So to get the angle of elevation that we have denoted as theta, the angle of elevation of the top of the tower is D from the point C. We need to actually use our trigonometry identity to solve for it, but we also need the value of another parameter. Okay, so if I'm to draw out the diagram, now I know AD. Okay, now I know AD, but I don't know AC. All right, this is theta AD. I just got to be 48.45 meters. So this is 48.45 meters. Okay. Now, with respect to theta, we know that for us to actually use a trigonometric identity, we need to find at least one of the other sides. But here, we can find a way to get our AC. Okay. So, to get that angle of elevation, we need to get the line AC. Now, can we get the line AC from any of the previous diagrams that we have? I think we can. Looking at the triangle ABC, we have the opposite, we have the hypotenuse. AC, in this case, is amounting to the adjacent from this triangle ABC, and I'm showing in the red circle. So, if I'm just to replicate this and bring it down to where I'm solving, it will just be very clear. So yes, this is what we're going to have now. So here, we have AB as the opposite. We found the value of AB initially. Okay, that's the very first thing that we did. We got to be 37.856 meters. Okay, now we know the hypotenuse. It was given the question 66 meters. We are looking for the adjacent. We want to use the Pythagoras theorem. Using the Pythagoras theorem, we know that the square of the hypotenuse, here hypotenuse is BC, is equal to the sum of the squares of the opposite and the adjacent, and that is AB and AC. So this is coming from hypotenuse raised to power 2 is opposite raised to power 2 plus adjacent raised to power 2. If we put in this value, that means we are going to have 66 raised to power 2 is equal to AB that's 37.856 raised to the power 2 plus the adjacent, the AC that we are looking for in order for us to get the angle of elevation of the top of the tower from point C. So that AC, if we just collect like terms, it will be 66 raised to the power 2 minus 37.856 raised to the power 2. Now there will be 66 square. That's 4356 minus 37.856 square. 1433.0767. Okay. So if you subtract that from 4356 minus our answer is 2922.923. So AC will be the square root of 2922.923. So if we are to find the square root of just the square root of our answer, that's 54.064 meters. Okay, that's the line AC. But nobody asked us to find the line AC. What we asked to find is the angle of elevation of the top of the tower from C. The top of the tower we have identified to be D. Now we have gotten the line AC to be 54.064 meters. So now we can get the angle of elevation that's theta reflected in this diagram. And with respect to theta, AD is the opposite, AC is the adjacent, then CD is the hypotenuse. So we have the adjacent, we have the opposite. We are looking for the angle. And what trigonometric function can we use? Opposite over adjacent, that is tan. Okay, so Katua, tan theta is opposite over adjacent. So we can say in this particular case, tan theta, which is opposite over adjacent, will just give us tan theta is equal to, the opposite is AD, okay, the adjacent is AC. So if we put in the values for AD and AC, that means tan theta will be equal to, AD is 48.4535, AC is 54.064. So if you are to use our calculator, 48.4535 divided by 54, okay, which is our answer. That was 0.8962. That's tan theta. So theta will be arctan, this ratio will be arctan 0.8962. So arctan shift tan, that's arctan of our answer, will be 41.86744998. Okay. But we're asked to find our answer correct to 2 decimal places. Okay, correct to 2 decimal places. So if you want to solve that, that will be 41.87 because 7 will be rounded up to 1 and added to the 6. So the angle of elevation of the top of the tower, as asked in the question, the angle of elevation of the top of the tower from the point C is what we denoted as theta, and that is 41.87 degrees. That's the solution to our question.